Hi everyone, in this lesson I will try to show you what's SubD modeling in a very simple fashion. SubD modeling is the main modeling approach of 3D modeling programs such as 3ds Max and Maya. If I may show you in 3ds Max how does SubD modeling works. Let's open 3ds Max up and have a look at SubD modeling in 3ds Max interface. In 3ds Max, opposite to Rhino, we don't create shapes or surfaces via curves. We mainly use basic geometrical structures and then shape them to the form we like. For example, if you want to draw a simple vase in 3ds Max, we can draw the side section of the vase and use a command like revolve in Rhinoceros, which is lathe in 3ds Max. But the main working structure in 3ds Max is drawing a simple geometry for the vase and drawing it with very little geometrical details. As you see, I'm drawing a cylinder with 8 sides only, and then we use a command called turbo smooth in 3ds Max to smooth this geometry up. As you see, the geometry becomes a very smooth shape without any hard edges. Then we can turn back to the basic shape and play with the edges or other elements of the geometry in the basic shape. The turbo smooth modifier gives us a smoothed organic form very easily. This modeling technique is very useful for creating amorphous shapes very easily and very fast. As you know, in Rhinoceros we need to draw curves to create surfaces, and drawing curves for fluid surfaces sometimes can be really hard, and this was a weak point of Rhinoceros in the past years. But with Rhino 7 we have the same SubD modeling capabilities. Normally, if we draw a cylinder in Rhino with the classic cylinder command, I'm drawing a cylinder with, for example, 15 centimeters of radius and 50 centimeters of height. So, if you draw a standard cylinder in Rhino, it's drawn perfectly with the dimensions you gave to the Rhino. But if you draw a SubD cylinder with the SubD cylinder command with the same dimensions, it doesn't appear to be a cylinder at all, because the target of the SubD commands is to create surfaces like 3ds Max creates with turbo smooth. So Rhino draws a cylinder but then smooths out the hard edges. In SubD modeling, there are two states of the geometry: the basic shape we are actually drawing and the shape which is given us after the subdivision processes. The surface you are seeing right now is SubD's result surface. If I close the SubD view with the tab button, you can see that I actually draw a pentagon prism, and then with smoothing out the edges, the result SubD surface appears. If we play with an vertex of this basic geometry, for example, the center vertex in here, I'm selecting it with Shift, Control and left click, and then if we pull it like this, as you are seeing, I'm playing with a very basic shape, but in the SubD result, I'm getting a very organic result. And as you can see, if I push it down, it doesn't create sharp edges. It gets to the bottom very smoothly. The main principle of SubD modeling is this. For the upcoming lessons, you need to know one simple rule for SubD modeling. SubD smooths out the sharp edges until it sees another edge. For example, you see SubD in the SubD result, this edge is smoothed out right here. There is a neighbor edge right here. So SubD sees this sharp edge and smooths the edge till this point. Have a look at it again. You see smoothing starts here and then makes the edge smooth. Then At this point, smoothing stops and the line, if we have a look at on the front view, the line starts to go down in a straight fashion, and then this sharp edge is smoothed between this edge and this edge. For example, if I delete these edges from the SubD surface, I will show you how to delete edges from surfaces or how to create edges on surfaces in the upcoming lessons. You don't need to try to do this right now. As you see, I'm selecting these two edge loops. I will explain what a loop is and deleting them. With these two edge loops deleted, have a look at the smoothing of this edge again. So right now you can see this edge is smoothing in a very large area until we reach to this edge. If you have a look at in the front view again, as you can see, smoothing continues till we reach to the next edge. The mechanic you see here is the foundation of SubD modeling. If we don't want this edge is being smoothed this aggressively, we need to restrict the smoothing by creating new edges near to this edge. For example, as I said, I will show you how to create these edges in the upcoming lessons. For example, if I create an edge right next to this edge, and now you can see smoothing is limited till here. And if I play with this edge, let us see the result on the SubD side. As you see, if I take this edge far away from the smoothed edge, smoothing occurs in a large area, or if I take it near to the edge we are smoothing, smoothing becomes very tight. If I take it higher than the neighbor edge, you can have a form like this in the SubD result, but we will never take an edge over and to the other side of a neighbor edge. Keep this in mind, please. At this point, you can ask me this question: if this is an H2, like this edge on the top, why isn't this edge bit smoothed? It's actually being smoothed, but the surfaces of this edge are in line with each other, so the smoothing doesn't create a difference in the final result. With the last example, I'm gonna finish this lesson. For example, you are seeing that our pentagon is rounded up to a smooth cylinder by SubD. If I get to inset these triangles with inset SubD tool, and then make extrusions of the smaller triangles. As you can see, I've drawn a very simple extruded geometry, but the SubD will round it up nicely, and we will have really organic shapes at the top of our cylinder. And then I can create some edges to get the smoothing under control for these triangles. As you see, they are not sharp pointy edges anymore. As you can see, SubD modeling is about managing our smoothed geometry by playing edges in our basic geometry. This was the foundation of SubD modeling. In the next lessons, we will begin to work on more meaningful models. See you in the next lesson.